we determine here the value of an triple integration. This is very important triple integration, and the integration is triple integration over r root under a square b square c square minus b square c square x square minus c square a square y square minus a square b square z square dx dy dz. And it is given that the value of the triple integration is pi square a square b square c square by 4, where the region or the volume of integration is given by the r. This is the ellipsoid. Okay, this is the given region of the integration. We first transform the equation x, y, z, that is the Cartesian coordinate, to another coordinate which is given by, that is, we first put x, this is equal to au, y, this is equal to bv, and z, this is equal to cw, right? And then we know that the Jacobian of this transformation is given by del of x, y, z by del of u, v, w. This is equal to determinant del x by del u, del x by del v, del x by del w, and similarly all the other two rows. And it is clear that del x by del u means a, this is a, and this is 0 and this is 0. So this is 0, this is 0. And similarly this is 0, b, 0, 0, 0, c. So the Jacobian is a, b, c for this transformation. Okay. So if we find out the mod value of Jacobian, this is also ABC. So we get the volume element dx, dy, dz. This becomes mod Jacobian into du, dv, dw. So this is ABC into du, dv, dw. Okay. Now we let here the volume of integration, okay, is transformed to another volume of integration which is known as r dash. Okay. So our given integration, if we name this integration is equal to I, then we can write I, this is equal to triple integration over r dash, and this is, if we put this value of x, y, z, then it is clear that we take common a square, b square, c square. This is 1 minus u square minus v square minus w square, and this is a, b, c, du, dv, dw. Okay. So we get the integration as integration over r dash. This is a square, b square, c square into root under 1 minus u square plus v square plus w square into du, dv, dw. Okay. And we see that this is r, the given ellipsoid, and r dash becomes u square plus v square plus w square. This is equal to 1. When we put x equal to au, y equal to bv, and z equal to cw, right? Now this is a sphere of radius 1. So we again apply spherical coordinate transformation, and which gives, we already discussed the spherical transformation or spherical coordinate transformation in previous class, and the link of this class is given in our description box. Okay. And what is the spherical transformation? In spherical transformation we put u, this is equal to r sin theta cos phi, v, this is equal to r sin theta sin phi, and w, this is equal to r cos theta. This is the spherical coordinate transformation formula. Now for this transformation we have to find the Jacobian of this transformation. and the Jacobian of this transformation we know as this is also delta of u v w by delta of r theta phi, because this transformation from u v w to r theta phi. Okay, and we also discussed in the previous class, if we take the complete sphere, here we take the complete sphere and the radius is 1, then the range of r, this is equal to 0 to 1, and the range of theta, this is equal to 0 to pi, and the range of phi, this is equal to 0 to 2 pi. Clear? These are the range of this spherical transformation or spherical coordinate transformation. Jacobian of this transformation is given by r square sine. So by this transformation we can write the elementary volume element of r dash is du, dv, dw, and the elementary volume element in r double dash, this is the new volume of the integration. Okay, and this is given by r square sine theta dr d theta d phi. Clear? And we also calculate this value in the previous class. If we want to see this video, then you can see this. Okay, now we putting the value of u v w in this integration, and we changing the range of the integration, that is the region or volume of the integration. This is given by a square b square c square. This is triple integration over r double dash, and this is given by 1 minus r square into r square sine theta dr d theta d phi. Okay, so this is the volume element. This becomes du, dv, dw, transform to this type, and this is the integrand. And we write here the range of the integration. We first write the range of r, this is equal to 0 to 1. Then we write the range of theta, this is equal to 0 to pi. And then we write the range of phi, this is equal to 0 to 2 pi. Since in integrand there is no term of phi, so we integrate first d phi or integrate with respect to d phi. Then we get from by integrating with respect to phi, we get a square b square c square into this is phi. Integrating the term theta, that is with respect to theta, we get the integration as minus cos theta, and the range is 0 to pi. Okay, and another integration is r equal to 0 to 1. This is r square into root under 1 minus r square dr. Now put r, this is equal to sine alpha, and then the range of alpha becomes from r to alpha, this is 0 to 1, this is 0 to pi by 2, and the integration of this term look like integration 0 to pi by 2. This is sine square, alpha, and this is cos alpha, and this is dr, so this is also cos alpha d alpha, and this is cos square alpha d alpha, right? And from these two terms we get, from here we get 2 pi a square b square c square, and from here we get this is 2, because cos pi is minus 1 minus cos 0, this is minus 1, and so minus minus plus, and that we get 2 from this term. Okay, so our total integration is 4 into pi into a square b square c square into this type of integration. Now if we integrate this term by using formula of gamma function, then we can write 4 pi a square b square c square into, this is written as 0 to pi by 2, this is sine square alpha minus sine to the power 4 alpha, d alpha, because we here write cos square alpha, this is equal to 1 minus sin square alpha. So this is the integration, and we write directly the result of two integration we know by using the gamma function formula. So 4 pi a square b square c square into, this is half into pi by 2, and this is minus 3 by 4 into half into pi by 2. So the final result is, we take common pi by 4, so we get 4 pi square a square b square c square by 4 into 1 minus 3 by 4, and so this is pi by cancel out, so we get from here, this is 1 by 4 and this is pi square this. So 1 by 4 pi square a square b square c square, and this our final result of this integration. This is